Did you know that there exists a place full of water ice that has never witnessed the presence of a human? But where is this mysterious location? Well, it's not on Earth, nor is it on any other planet. It's a moon right within our own solar system. Welcome to Youniverse Revealed. Today, we will explore the most unique as well as the most potentially habitable moon in our solar system. And joining us on this exploration is one of NASA's most significant upcoming missions, Dragonfly. Dragonfly is a special spacecraft that NASA is planning to send to Titan, Saturn's biggest moon. The plan is to send a robotic rotocraft to the surface of Titan. The main goal of Dragonfly is to see if Titan could support life. It will study the chemicals that might support it. Dragonfly's ability to take off and land vertically is known as VTOL, vertical takeoff and landing. This will let it move between different sites for exploration. So Dragonfly, our flying robot, will fly around Titan, visiting many different locations on the surface. This way, scientists can learn about many different areas and get samples from the rocks and land. The mission is all about exploring Titan's potential for life and understanding its chemistry. The launch of Dragonfly is scheduled for July 2028, and it's expected to reach Titan in 2034. This mission is important. It will mark the first time an aircraft has flown on Titan or any moon in our solar system. The main aim is to have the first powered and fully controlled flight outside of Earth. The goal is to study the chemistry before life began and to see if Titan could support life. But why Titan? Titan has a hidden ocean beneath its frigid surface that has long waited to be explored. This ocean isn't just any ocean. It could be larger than all the oceans on Earth combined. Imagine a vast expanse of liquid hidden beneath Titan's frozen crust, sloshing quietly in the depths below. But that's not all. Titan boasts a landscape reminiscent of Earth with clouds, rain, and flowing rivers. Instead of water, these rivers and lakes are filled with liquid hydrocarbons. These hydrocarbons include methane and ethane. Some of these seas are huge. They stretch hundreds of miles wide and plunge hundreds of feet deep. Yet beneath this icy shell and hydrocarbon-filled seas lies another layer of liquid, an ocean primarily made of water, not methane. Yeah, you heard that right. This discovery is unprecedented beyond our planet. It's a testament to the mysteries waiting in the vastness of space. And that's not all. Scientists have found big tides on Titan. This suggests the hidden ocean is moving. It's likely to be swirling under the surface. This revelation opens new doors for our understanding of celestial bodies. They may have environments like Earth's, which sparks wonder in our exploration of the cosmos. Titan is a fascinating place to study astrobiology. Its surface has a lot of complex life-supporting chemicals. There's a chance that there might be both temporary liquid water and liquid hydrocarbons on the surface. This mix could create a place similar to where life started on Earth. Because of all these factors, scientists want to explore Titan. They want to learn more about the possibility of life beyond Earth. The idea for the Dragonfly mission was put forward in April 2017. This was part of NASA's New Frontiers program, powered by the Johns Hopkins Applied Physics Laboratory. Out of 12 proposals, Dragonfly was chosen as one of the 2 finalists in December 2017. Then on June 27, 2019, it was selected to be the 4th mission in the New Frontiers program. Oh, and it's not just about finding life on Titan. There's more to this mission. Titan is quite similar to early Earth, so studying it can give us clues about how life might have started out on our planet. Back in 2005, the European Space Agency's Huygens lander gathered some data about Titan's atmosphere and surface. It found something called tholins, which are a mix of different types of organic compounds. These mainly consist of hydrocarbons in the atmosphere and on the surface of Titan. Due to Titan's thick atmosphere, it's hard to see what's on the surface at many wavelengths. So we don't really know exactly what kinds of solid hydrocarbon materials are there. Through the analysis of material compositions across different regions of Titan's surface, scientists aim to determine the progression of certain chemical processes, including those potentially leading to life. They're especially interested in finding things like pyrimidines, which are important for DNA and amino acids. These are the building blocks of proteins. This information could give us clues about whether Titan has the right conditions for life to exist. Dragonfly is particularly interested in places where there might have been liquid water from outside sources, like from the impacts or possible icy volcanic flows, mixing with many organic compounds on Titan. Titan's atmosphere has a lot of nitrogen and methane, and there's strong evidence that there's liquid methane on the surface. There's also evidence suggesting that there could be liquid water and ammonia beneath the surface, possibly pushed up by icy volcanoes. Liquid water, possibility of life, and carbon compounds. It all sounds way too promising, doesn't it? Maybe we end up finding our new home on this moon. But who first thought of exploring this super promising moon? The idea for Dragonfly started with a casual dinner chat between two scientists, Jason W. Barnes from University of Idaho and Ralph Lorenz from Johns Hopkins University Applied Physics Laboratory. Jason Barnes had already proposed a similar idea for an aircraft to explore Titan he called Avatar. After their conversation, it took about 15 months to develop the idea into a detailed plan for a mission. The main person in charge of the Dragonfly mission is Elizabeth Turtle. She is a planetary scientist at the Johns Hopkins Applied Physics Laboratory. She leads the team responsible for making this mission a reality. The Dragonfly mission is based on previous studies exploring how to uncover Titan from thin air. One study in 2007 suggested using a large balloon called a Montgolfier balloon to explore different regions of the moon. Another concept called Avatar, which was considered for another program called Discovery, proposed using an airplane to explore Titan. Then in 2000, Lawrence first suggested the idea of a rotorcraft lander. It could fly using battery power and recharge during Titan's long night, which was about 8 Earth days. It would use a radioisotope power source. Dragonfly will use its multi-rotor vehicle to carry its instruments to different places on Titan. It will examine things like the material of the surface, the nature of the atmosphere, and the factors that are altering the landscape. Dragonfly and Caesar were the final 2 options for Mission 4 in NASA's New Frontiers program. But on June 27, 2019, NASA chose Dragonfly to move forward with development, aiming for a launch in June 2027. On March 3, 2023, Dragonfly successfully completed its preliminary design review. This marked an important milestone in its development. However, the path to success is always filled with challenges. In November 2023, due to uncertainties in funding, NASA decided to postpone formally confirming the mission. This delay pushed the launch date back by a year, with the new launch date set for July 2028. So now Dragonfly is set to launch in July 2028, and will take about 7 years to reach Titan, arriving around 2034. To speed up its journey, the spacecraft is likely to use Earth's gravity to get an extra boost of speed. Interestingly, unlike many space missions that usually stop by Jupiter, Dragonfly won't, because Jupiter is not on its path. Once Dragonfly reaches Titan, it is set to land first in a sand dune. This location is southeast of the Selk impact structure. It's also near a dark area known as Shangri-La. From there, it will explore the region through a series of flights, each covering up to around 5 miles, or 8 kilometers. The goal is to collect samples from different places with diverse geography. After that, Dragonfly plans to head to the Selk impact crater, where there's evidence suggesting that liquid water might have been present in the past along with organic compounds like tholins. The Selk crater is a relatively young impact crater, around 56 miles wide, located roughly 500 miles north-northwest of where the Huygens lander touched down. The Cassini orbiter took measurements, including infrared readings and other types of spectral analysis. These show that the area around the crater is brighter. This brightness could mean there are differences in temperature or composition. These differences might have been caused by cryovolcanism, triggered by the impact. The crater might have led to the release of material that flowed like a fluid and has since frozen into water ice. This area where organic compounds and water ice come together is fascinating. It gives us a chance to see how much certain chemical processes have advanced on Titan's surface. These processes could be related to the start of life. If Dragonfly successfully flies on Titan, it will become the second rotorcraft ever to fly on a celestial body other than Earth. The first one was Ingenuity, a small helicopter that flew on Mars as part of the Mars 2020 mission. Ingenuity landed with Perseverance rover on February 18, 2021, and it completed its first powered flight on April 19, 2021. And now it's time for Dragonfly. And you never know, we might discover signs of life with a different chemistry than what we're used to.